From the high desert and the great American Southwest, I bid you all good evening, good morning, good afternoon, whatever the case is, wherever you are, and it truly is worldwide. We're covering the world. It's really great to be here, folks. It really is. We've got Nassim Haramein on tonight. He is a physicist, has been compared to Tesla, actually. Not a doctorate, but he sure knows what he's talking about. What a world. He'll be coming to us from a hotel in Paris, France. So a couple things I want to get out of the way, and then we'll get on with that. It's going to be fascinating. Sorry to report. We've got, breaking news, of course. Not good stuff, never is, right? Lafayette, Louisiana. May have heard about it. Some mentally deranged person, I'm sure it's got to be that, went into a movie theater in Lafayette and began shooting. Shot total of 11. That would include himself. He's dead. He committed suicide. So 9 are shot, from what I can get, and 2 are dead. And my only comment on these head shakers is this country's not doing enough for mental health. Ronald Reagan, who I really admired, did something I did not admire, and that was release so many from institutions. It's not guns, can't blame them. It's mentally ill people. I mean, think about it for just 1 second, because I certainly have, and that is, if you wanted to go out, take yourself out, let's say, and you had even the slightest inkling that there was a hereafter, would you murder a bunch of people randomly and then shoot yourself? No. And I think most of us have an inkling that there is a hereafter, don't we? Sure we do. I do anyway. So a couple of other items, leaving that one quickly. A renowned theoretical physicist and cosmologist, Stephen Hawking, has launched now the most extensive search for intelligent alien life on other planets. This is big news. In an infinite universe, he said, there must be other occurrences of life. He launched today the $100 million 10-year project at the Royal Society Science Academy in London. Now, they're going to be listening really, really hard. It's funded by a Russian tech entrepreneur, Yuri Milner. They're going to be using satellite dishes, big satellite dishes in West Virginia, I believe. And where else? United States Parks Telescope in New South Wales, so Australia. So there you go. And the other news on that front is we have a sister planet, Earth 2.0, they now call it. This is dubbed Kepler 452b. It's in a 385-day orbit around its sun, and it's probably Earth 2.0. It is, of course, it's been created 6 billion years ago, so if it's got the stuff of life, water, air, whatever, it's just like Earth, but it's 1,400 light years from Earth. Translated, that means if you could fly at the speed of light, it would take you 1,400 years to get there. 1,400. So even if they were madly sending signals, they would have had to have been sending them for some time. Well, there may be life there. There really may be. All right. Now, the big one. Last night, at the beginning of the program, I said I would like to connect with Anonymous, the hacker group, the group Anonymous. They're not really a group. So between the time I said that last night and now, I have learned more than most people want to know about Anonymous. However, I'm going to read you an email that I received, and I'm pretty darn sure I'm in contact. I had a number of emails today that said, well, Art, you wanted to hear from Anonymous. You better check your Twitter. Good luck. So I got this email today, and I want to read it to you, and it was I'll give you my impression after I read it. Art, you had speculated that Anonymous was probably involved in the New York Stock Exchange outage last week. I do not believe this to be the case for the following reasons. Even though the warning was posted by an establishment media outlet of the Anonymous hive mind, that would be at Your Anon News on Twitter, among others, it was not done in the typical style of Anonymous warning a target. In other words, there was no media blitz, no computer-generated featurette on YouTube to warn the target and recruit Anons. No press release on any of the anonymous text posting services like Pastebin, and no dissemination of links to pages containing relevant reconnaissance information and operational security tips to Anons who are not plugged into the usual communication channels but who still may wish to take part. From the information available at this time from news outlets, the New York Stock Exchange, and anonymous related sources, I do not believe the anonymous warning to have been a threat. Instead, it is my considered belief from analysis of the information that Anons who work for the New York Stock Exchange in some capacity began to see things happening that they believed were potentially damaging. Buggy software updates, hardware problems that were not going to be solved before the start of business the next day, or something else along those lines, and attempted to warn people through those anonymous media outlets. It's typical that anonymous social media and propaganda outlets are operated by multiple individuals simultaneously. So, if this is in fact the case, it would not be surprising that there are members of the anonymous hive mind that work for the New York Stock Exchange. Anonymous is one of the most socially and economically diverse groups out there. Group is not the proper term. Adherent of the anonymous meme is more correct. There are Anons who are precocious youngsters in middle school, parents, active duty soldiers, police officers, programmers. To blame Anonymous for a specific attack is to mistake membership in or adherence to a meme with the existence of an actual attack. To put it another way, and I believe you will understand as you are in possession of no small degree of technical skill due to your background, Douglas Adams once famously said, "We're stuck with technology when what we really want is just stuff that works." So after reading this, I said to myself, okay, this is the one. I mean, clearly he knows what he's saying. So I can't promise this, but it is possible that tomorrow night we may get a means of communication from the person who wrote what I just read to you. Nassim Haramein was born. So I've connected with Anonymous, obviously, and we'll see where it goes from here. My wife, who is Filipina, as you know, is obviously connected enough to ask me, "You did what?" I told him I wanted to talk to somebody from Anonymous. Anyway, Nassim Haramein was born in Geneva, Switzerland in 1962. As early as 9 years old, he was already discovering the universal dynamics of matter and energy, which led him on a journey toward pioneering a new approach to quantum gravity and continual developments in unified field theory. He grew up in eastern Canada with an innate reverence for the design or nature and a determination to discover the basic building blocks of creation. Nassim dedicated most of his time to independent investigation into physics, geometry, chemistry, biology, consciousness, that's a big one, archaeology, various world religions. His dedication to scientific exploration combined with his keen observation of the behavior of nature led him to a specific a geometric pattern which is at the core of his approach and the new perspective in unified field theory. He's got a couple of young sons that he raises in Hawaii. However, at the moment, believe it or not, what a world, he's in a hotel room in Paris, France, which is where we're going to be going shortly. He's quite an amazing individual, in my opinion, just an absolutely amazing individual. So we're going to have fun. We're going to talk to him. We're going to ask him about, I think, the things we all want to know about. So that's coming up. This is Midnight in the Desert. Stay right where you are. Paris, France. Can you believe that? What a world! And wait till you hear how he sounds. It's all coming up next.
No call screening. No waiting on hold. No requirement to kiss Art's ring. Just good talk. Join Art by calling 1-952-225-5278. That's 1-952. Call Art.
All right. I just have one more comment on Anon, folks. Thank you for all the contact. Don't hurt me. It's going to be a good interview. I'm just interested in the philosophy. I've heard a number of recordings from that group, so don't get me. All right, let's see if we can go all the way to Paris, France, and say hello, Nassim. You're on the air.
Hi, Art.
Hi, it's great to have you. Really in Paris, huh?
Yeah, I am. I've been traveling a lot, and down here having a few meetings.
I am so jealous. I've been there a number of times, Nassim, and it is such a gorgeous place. God.
Absolutely.
I wonder something. Tell me something, Nassim. How can something so old as Paris look so doggone good? I mean, everything is stone. Everything is clean. It's staggering.
It's amazing, isn't it?
Yes.
And when you look at Paris layout, the way the streets are laid out and the geometry of the whole thing, it's an amazing thing, actually.
It is.
It's remarkable. There's no, 90 angled corners or very little. It's all round.
That's right.
And it's an amazing setup. It's a little bit hard to navigate, but you get used to it.
Yeah, that's okay. I just went down by the Seine, sat down with some nice French bread and some wine, and anyway.
Good food, for sure.
Yeah, down to business here. You're a physicist. Now, you don't have a doctorate. Many have compared you favorably with, for example, Tesla. You've studied physics for 30 years. And so I guess the first and most obvious question is, what in the world led you into the field?
Well, I think it was a natural curiosity right from the beginning when I was young, trying to, like most people are born and then they just having this experience we call life, and they don't really think twice about it. But for me, it was like, how is this happening? How is it that I'm alive? And what is all this stuff around me? And how did it get there? And how did I get here? Yeah. And all that were really kind of fundamental questions that I thought had to be addressed. And so I kind of launched myself on a journey to try to figure some of this stuff out.
Have you figured some of this stuff out?
I think so. Although as you get older and wiser, you start to feel that you haven't maybe figured it out as much as you thought you did. But
that's right.
Yeah.
All right. So where do we launch here? I'm going to ask that you keep this discussion sort of at a human level. When we get into physics, it's rough going, and understanding things requires somebody who can explain it in normal human words.
Mm-hmm. Yes, I'll try to keep it as layman as I can.
Okay. I can see from some of what you've written that may not be easy.
Go ahead.
I am very, very, very interested in consciousness. And I wonder, I guess you feel that everything is connected. Yes?
Absolutely. It's not just a feeling, it's a function of how things are. You can't really isolate anything from anything else. Gravitational field, electromagnetic field, and so on cannot be completely shielded. And so everything is kind of interacting with everything, and we have lots of evidence in quantum field theory and quantum quantum mechanics that's the case, that things are interacting at a level that's not necessarily obvious.
Oh, very much not obvious. Whenever I have a physicist on, I try to have him explain to me the concept or the apparent reality of quantum entanglement. Now, I want to give you a shot at it. It's where one particle. Let me try. It's when one particle is next to another particle and they get into some kind of sync or they recognize each other. It's like shaking hands. Then you can take particle B, to Paris, for example, from where I am here in the desert, and both of these particles are flipping and flopping in exactly the same way, as if they are, in communication.
Yes, they're instantaneously connected, no matter how far they are from each other. One could be on the other side of the universe. And if you polarize this one in a certain polarity angle over here, the other one will change its polarity angle instantaneously. It's remarkable.
Right. Instantaneously is the word. In other words, perhaps even exceeding, if we're talking about communication, and we'll get to that, if we were, it would be at the speed of light or better, right?
Yeah, way faster.
Way faster.
It's instantaneous, no matter how far it is.
Exciting.
Yeah, and so we've been able to test this because we can get particles on Earth far enough apart that even at the speed of light, we could see a delay in the reaction of the entangled particle, and we're unable to measure any delay. It's instantaneous.
That's impossible.
Well, it's impossible if we think of things being separate from each other, but it's possible if we think of things being part of one fundamental network that everything interacts with.
But it in the way you just described it, for example, you said if you were to get one of the particles at one particular angle, the other would it's impossible, Nassim. It's impossible. And if it is possible, how? And if you don't know, which I don't think you do, don't be afraid to say you don't know. I can't fathom it. I've thought about this again and again and again, and it just won't come to me.
Right. Actually, it's a really, really good question that hasn't been answered very clearly at all from the mainstream, except for the last few years where finally something that I mentioned many, many moons ago, there is very famous physicists that are writing papers showing that most likely even subatomic particles are connected through what is called wormholes, which were never usually applied to entanglement because wormholes are a consequence of Einstein's equations, which usually deals with the big stuff, with the cosmological stuff, not the small stuff of quantum theory. So, but now it's becoming more and more obvious, and it's becoming realized that particles may be connected by teeny-weeny wormholes, and that these wormholes is what is transferring the information, instantaneously across scales.
That's fascinating. All right. Well, normally my idea of a wormhole was a sun that collapses, right, and creates this monster of a wormhole.
This monster of a black hole that may generate wormholes.
I'm sorry. Yes, a black hole, and then you could have wormholes.
That's right. And so it's starting to become obvious, and really we're starting diving deep. This is probably some of the most bleeding edge of physics right now. It's becoming clear that black holes seem to be connected through wormholes,
right? And
that black holes are not just cosmological objects like the sizes of stars or the center of galaxies or things like that, but actually particles, subatomic particles that are really, really teeny,
right,
maybe as well acting as black holes and be connected through wormholes.
Through what method? In other words, when we get a black hole, we know a sun collapses. But at the atomic level, what can possibly occur to create such a... Well, they're powerful in what they allow, right?
Yeah, such an energetic event, as a black hole.
Right.
That's a really, really good question, Art. And, to understand that, we have to bring in something that's called the quantum vacuum fluctuations, or the 0-point energy, as it's more popularly known. And it has to do that when you look at the very, very fine level, when you look at like the basis of space-time at the way below the atomic structure, way below the nuclei of an atom, like at the very, very fine level, what we find is that it's not empty, that space is not empty at that scale. It's actually full of energy, and that energy may be the source of what's fueling these mini black holes that we end up experiencing as subatomic particles.
Well, I've heard it's speculated that there are very small, relatively small black holes that one could even, for example, pass through the Earth and we might not even know it. Is that possible?
Absolutely. And there's been a certain amount of search for some of these very small black holes even inside our solar system. This might sound shocking, but as a result of the mathematics that I wrote, which predicted very, very accurately, actually more accurately than any other theory on Earth today, the mass and radius of a proton, which is the nuclei of an atom or matter. Right. I've been able to say or to show very, very clearly that actually what we think of the nuclei of an atom acts very much like the nuclei of a galaxy, which is, a black hole structure.
That kind of makes sense, actually.
Yeah, it's kind of like as above, so below.
So below, yes.
Kind of thing. And because everything is inside everything, meaning that all matter is inside our universe, and if everything is entangled, the mass of the universe would be shared across all atoms, and actually that interaction, you could say that the information moving from one point to another in the universe is actually what we experience as our reality, or the material world we see. It's a little bit hard concept to visualize, but you have to realize that when we're talking about the nuclei of an atom, like a proton, or even an atom itself, all we're talking about is that in that region of space, we can see there's a dense electromagnetic field, electrostatic field that seems to have a boundary, but we're not seeing like billiard balls. That's a thing we gotta get out of our head.
Right. I want to sort of apply this or walk back to consciousness and how that might or might not fit in a little bit with what we're talking about. They're doing this fascinating experiment. I'm sure you've heard of it at Princeton University, the egg thing, where
yes.
they're watching mass consciousness and all the rest of that, and the idea that we are all connected. So we'll touch on that when we get back. Stay right where you are. Nassim Haramein is my guest from Paris, France. I'm Art Bell, and this is Midnight in the Desert.
For Dark Matter News, I'm Leo Ashcraft. It's a pursuit nearly as old as the infamous shipwreck itself. Divers have plunged into the waters off of Nantucket, Massachusetts to catch a glimpse of the Andrea Doria a day after the ship sank in July 1956. The first dive netted photos for Life magazine. Later, an expedition led to a documentary about the deadly shipwreck, which killed more than 50 people when the Italian luxury liner collided with another ship. For decades, the site became so popular with daring divers that it is known as the Mount Everest of wreck diving. Officials have long warned that it's dangerous to dive to get to the shipwreck site, 240 feet underwater. In the past decades alone, the Coast Guard says 7 people set out to reach the wreck and never returned. Another diver went missing this week and is presumed dead. The Coast Guard said it suspended the search for the missing 64-year-old man Wednesday night and notified his next of kin. The extremely controversial Jade Helm 15 military exercise, which is scheduled to run from July 15th to September 15th in at least 7 states, including hostile Texas, will be entirely off limits to reporters, according to a military spokesman. The Jade Helm exercise, which was originally set to consist of more than 1,200 special operations personnel, has been talked about amongst conspiracy theorists and members of the general public for months now. Due to this public outcry, a U.S. Army lieutenant colonel has announced that the operation will be slimmed down to a mere 200 special op forces and 300 support personnel. An additional 700 personnel will be deployed to Texas in August for 5 days, as reported by the Washington Post. During the exercise, military personnel dressed like civilians will move amongst the populace undetected, according to the documentation already presented. This is Dark Matter News. Those bright spots on Ceres just won't go away, will they? While New Horizons and the dwarf planet Pluto might have been hogging the limelight recently, the Dawn spacecraft deserves its fair share of attention too, and it may be close to solving the mystery of the bright spots on fellow dwarf planet Ceres. Ever since Dawn entered orbit around Ceres earlier this year, scientists have been left baffled by the appearance of bright spots seemingly redirecting sunlight in craters on the surface. Theories of their origin have ranged from ice, exposed by impacts on the surface, to salt flats or even cryovolcanoes. Now scientists might be closer to solving the mystery by spotting a haze above the group of spots, suggesting their origin is ice. The latest findings were revealed by Christopher Russell, the principal investigator on the mission, at an exploration meeting at NASA's Ames Research Center earlier this week. If confirmed, this could be the first such haze ever found in the asteroid belt and could indicate the presence of ice turning into gas, known as sublimation, on Ceres. The haze was found confined to the Okater crater, which contains the most famous spots on the surface labeled Spot 5. More than a quarter of Ceres' mass is thought to be composed of water, the other 3/4 rock, much more than is thought to be present on asteroids. Whether these spots are made up of water ice, though, or something else entirely, has been up for debate. Now, this discovery of haze lends strong evidence to the ice theory. Dawn is continuing to spiral closer and closer to Ceres as it lowers its orbit, and by August it will be 1,500 kilometers above the surface, compared to less than 4,000 kilometers now. It will also use its infrared spectrometer, which should be able to work out if the spots are made of ice or salt. By August, then, we can expect to have much better understanding of the bright spots. Whatever they turn out to be, the answer is sure to provide a fascinating insight into some of the processes taking place on Ceres. I'm Leo Ashcraft for Dark Matter News.
Come on, men and women. Skype up. Call Midnight in the Desert at MITD 51. That's MITD 51.
God, I absolutely love that song. I just love it. So you heard more of it than usual. If everything is connected, well, then somehow that song makes sense to me. Nassim Haramein is my guest, and he founded the Hawaii Institute for Unified Physics. He does not have a doctorate. However, he's an incredibly bright guy. You can go look him up. Nassim, have you published, by the way?
Yeah, I've published multiple papers in physics. Some of them are very controversial, describing the nuclei of an atom as a mini black hole. Mm-hmm. But the latest one, making a prediction of actually exactly the radius and the mass of that mini black hole we call the nuclei of an atom, or the proton.
Yes.
And as well, predicting how that black hole would behave in terms of its strength and gravity, attracting other little protons, and proving that that force is exactly what's holding the nuclei together, not the typical strong force described in quantum mechanics.
What has to be done to prove your prediction?
When I published it, what needed to be done is an accurate measurement of the radius of the proton, which I thought, oh my God, I might not be around by the time that's done, and I might never see that happen. And then, unbeknown to me, an experiment was actually being carried out in Switzerland in an accelerator to measure more precisely the radius of the proton than ever. And it was published about 2 months after I published my paper. And the prediction startled the measurement startled the scientific community because it was too small to support the standard model of physics. But it was exact to my model.
Wow. I would assume you're talking about CERN, the super collider?
No, it's a proton accelerator, the Gerard accelerator in Switzerland, that is specialized in measuring such things. And it was really amazing that it happened so quickly and that my prediction got confirmed so fast. And to this day, it's the most precise theoretical model to predict what's actually happening down there in terms of the energy and the geometry of a proton, which is really important because it's like basically the mass of the atom, the mass of reality, how reality comes about. And what it says is really incredible because it actually says that all the protons are acting upon each other, and that the system is one big holographic system. And the way their equations are written, it shows that like all the information of all the other protons in the universe are present in one single proton. And in terms of vacuum fluctuation, in terms of information inside the volume of one proton, a little bit like a CD-ROM might have an orchestra on it. Of course, the violinist and the violin and the cello and all this is not literally on the CD-ROM, but the information is there, the music is there. It's like all the information of everything else in the universe is present in one single particle, and its interaction together is what, like the information moving through the thing. This is how I made the equation. Actually predicts the correct mass and radius of that proton. So it's really saying the universe itself.
Okay, we got you back. There was a brief little interruption there. Let me ask this: you made the prediction, which is really sticking your neck out, and it was all done with mathematics. You said, right?
Right.
Okay. Were you given a few accolades from other physicists? You would classify yourself as a theoretical physicist, I presume, yes?
Yes.
Uh-huh.
I received some accolades from some, and a lot of tomatoes throwing from others.
Really?
Yes.
The ones throwing the tomatoes, what were they saying?
They tried to dismiss the mathematics and the equation, and
was that before or after it was measured and it was verified?
Before and after.
And after. Now, see, that's not science.
I know, it's remarkable. Even some of the people that made the measurement came at me, but the math is bulletproof. The math is solid, and it's very simple, actually. It's a simple volume to surface ratio of these little Planck information bits in the vacuum. And it really outputs, and you know what's incredible, Art, is that these equations, basically they're describing the information that's in the field of energy we call the vacuum structure at the quantum level. And when you're doing the equation, you're actually using huge numbers. Because these bits of information are so teeny. There's a lot of them inside a proton. So you're using numbers that are equivalent to the mass of the universe and all this stuff. And when you're done with the equation, it outputs an exact value for the proton, which is a teeny little thing. So it's really unlikely that it's arbitrary.
All right. For those who don't know about it and want to do some heavy reading, your latest paper is called Quantum Gravity and the Holographic Mass. Is that correct?
That's correct.
All right. Is it published? Is it on the internet? Can they find it?
Yes. Yeah, absolutely. You can find it on our site, or you can find it on the scientific journal site where it was published. It was peer-reviewed there in an open peer review, so you can even read the peer review comments.
Way to go.
And it is, it is unconventional, of course.
Yes.
However, a lot of evidence is emerging that supports this view. And, the math is the math is the math. And when it does good prediction, I'll give you another idea, is that, in some 2 decades or more of string theory trying to be pushed forward to unify physics,
yes,
not one single prediction was made that could be verified in the laboratory. Not one single prediction. Yet, this theory, within months of being published, produced a very, very important prediction. And so it's very compelling. And it's really simple. That's the crazy part about it. And that's some of the criticism I get, is that it seemed too simple. Well,
some of what Einstein produced turned out to be pretty simple and short too, right?
Exactly. And it's commonly known that typically when a simple and beautiful solution is found, it's the correct one.
I'm told that the final solution someday, and that which people in your in your line of work pursue, is this theory of everything that some say may turn out to be no longer than your thumb.
Right, exactly. That when we find a unified view of not only physics but literally everything,
yes,
it would be beautiful and simple, and it would make sense, right? And certainly string theory is not that. It's very complex, and it predicts things that are not really useful. For instance, you could.
I interview frequently the man who was, I guess, co-author of the string theory. I guess Michio Kaku, professor.
Yes, absolutely.
And I frequently interview him, and so let's talk string theory a little bit. You say it predicts things that don't make sense, or?
Well, the result of string theory is unclear, meaning there's 10 to the 400 and some, or 86 different ways of compactifying the strings. There's not, it doesn't give you clear answer. It's extremely complex. It's written in 10 or 11 dimensions. And it doesn't really give us a clear picture of how this universe is producing all this material world that we live in, and certainly it says nothing about how consciousness emerged from it. And so, a lot of theorists in the last few years have been turning away from string theory because it seems like it's lacking elegance.
I've heard that some are turning away from it. What about the multiverse theory that seems to go with the string theory? Do you think the whole concept of multiverse existence collapses without string theory being so, or is there some way in which you can see multiple dimensions?
Yeah, I think that the multiverse can remain, but it becomes much less esoteric in terms of the way it's functioning. It's more mechanical. It makes more sense. That is, that our universe is not most likely not isolated, is probably part of a larger universe, which is part of a larger universe, which is part of a larger universe again, and so on. So it's more like fractal universes instead of parallel ones.
I can embrace that idea as well. I can see that. It goes from the very largest to the very smallest.
Very smallest.
Yes.
That's right. And when you look at the bubble we call our universe today, and we have some idea of its radius, and you put the mass that we observe in our universe in it, our universe obeys the exact quantity or the exact density of a black hole.
In other words, all the rules are followed.
That's right. And so if our universe is a black hole, most likely the material stuff we see in it are mini black holes as well, and so on. And so basically it's kind of scales of black holes from infinitely big to infinitely small.
All right. I'm going to venture all over the place, and I'm just going to ask you about this. And you're from Switzerland. The CERN devices, Super Collider, the big mama, they're really cranking it up. I think they're taking the voltage way, way up. And I've asked a number of people about this and would like to ask you, is there any possibility, in your opinion, of danger with what they're doing?
Yeah, that's a complex question. I think in general, no. I think in general, what they're doing is, it's colliding proton at very, 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 very high velocity with each other. Now, if my theory, and, I was invited to present, when I made this prediction, I was then shortly thereafter invited to present my paper at CERN, which was canceled promptly by the director. But my predict, if we take my theory and then we apply it to what's going on at CERN, it's probably not the best idea to collide little protons together.
No.
If they're all connected, we're probably sending shockwaves.
No, wait a minute. See, I just said, is there any possible danger in what they're doing? And now you seem to be, after saying no, describing possible danger.
Well, it's probably creating some noise on the structure of space-time that may not be the best thing to do. Is it endangering our health directly and so on? I think the effect is so minimal that we don't necessarily experience it. But I would say that even all right, let me ask you this. Is your only concern for the poor little colliding particles, or is there a possibility that something else might occur in the continuum that all of us might not like? I think it could be, absolutely. But I don't think we're any close to the energy levels I would require to do something very, very dramatic. I think those energy levels are way above what the standard model predicts. Just because of the way the equations I wrote are set up.
Okay, I'm not a physicist, but, little things can make big bangs, and we know that. And so if we collide the wrong thing with the wrong thing at the wrong speed, you couldn't exactly say there's 100% no problem, because we're off into territory that we don't understand fully, right?
Exactly. And certainly, even in the standard model, there's an outside possibility of creating, an entity that wouldn't be a healthy thing to have around.
Wait. Entity?
I meant it in terms of a particle. A black hole.
On this program, you have to be careful about saying entity.
I'm sorry. But it will, like I said, the energy levels are not there. I would be more concerned. I am actually more concerned about the the electromagnets in the device being so strong, and their influence on the electromagnetic field of the Earth and the ionosphere and so on. Because
I have never heard anybody say that. I've never. They are obviously very, very, very strong magnets, right?
Exactly, and it creates a very high
magnetic force
in that region, which, the Earth's magnetic field, is influenced by. And actually, I'm more concerned about that than what they're producing inside the accelerator.
I recently heard that our magnetic field, Nassim, is weakening significantly. Yes?
Mm-hmm. Yeah, there's been spotting, which is typical of what we've observed from records in the lava of the beginning of magnetic pole shift. And so there is a weakening of the magnetic field, and there's spotting that's occurring. And spotting is like when if you're in the north hemisphere, all of a sudden there's little spots of south polarity, showing up and so on. And so it's and the poles are drifting significantly as well. And all of those things are indication of magnetic pole shift.
How about the word precursor? Precursors to a pole shift.
Right.
See, now you are the second person, Nassim, to say that to me in 2 days. Hold it right there. Stand by. We're going to take a break. Second person to say that in 2 days. Pole shift. Doesn't sound good, does it? Doesn't sound good to me anyway, at all. Pole shift. North of south, south of north. And who knows what the plates do. You're listening to Midnight in the Desert.
Midnight Matter can be explored on Midnight in the Desert with Art Bell. If using Skype from your computer, please be sure to use a headset mic and call MITD 51. That's MITD 51.
There he went again, stumbling a little bit. Stupid machine. All right, welcome back, everybody. There is so much to talk about. Nassim Haramein is here with us, and he's coming all the way. So if you hear an occasional crackle or whatever, he's in Paris at a hotel, and so I'm astounded that we hear him as well as we actually do. So once again, welcome back, and we left it at pole shift. I'm coming back to consciousness eventually, but pole shift. When you hear pole shift from two people in 2 days, and you start thinking about it drifting and doing all kinds of precursor things that people are talking about, I can't resist asking you, Nassim, about the possibility of a pole shift. If that were to occur, and frankly, we're overdue for it.
Mm-hmm. That's right, we're overdue.
Yeah.
We know that it's flipped many, many times before.
Right.
From records in the lava where the particles align to the magnetic field of the Earth. So we know it's flipped a bunch of times, and we seem to be overdue for one. And the way the magnetic field is behaving right now seem to be suspiciously confirming that we're about to have one.
Well, let's say we have one. Let's say we have a pole flip. What do you believe we can expect? We humans can expect, the animals of the planet, the perhaps the mammals, the fish, the birds, and then of course, us.
They could be significant disruption, that as a result of a magnetic pole shift, many of our technologies would be disrupted. The way birds navigate, the way some of the marine mammals navigate, and so on, could be very much disrupted, and it could have some significant impact on our civilization. Just because our civilization is technically and technologically very much tied into the expecting the electromagnetic field and magnetic field of the Earth to be stable and to be polarized in a certain way.
We definitely depend on it, yes.
That's right. But I think overall we would survive the event quite well. You can think of it as our sun, for instance, which is some 99.8% the mass of our solar system. Every 11 years, our sun flips its poles. Some people may not be aware of that.
Well, it's true.
And we don't experience huge impact from that, either than the sun becomes very active and throws out sun flares, and if we were hit by one of those sun flares, like directly, could be catastrophic for the Earth.
Well, here's the thing. Let me just interject. We do have the magnetic field, which is exactly what protects us from those sun flares, right? So if it gets really, really weak before it decides to do its flip thing, and there's a big sun flare, it'll cook us alive, literally.
Yeah, it could be a big problem. For instance, if it got really weak, even without a big sun flare, just from galactic cosmic rays and radiation from the sun and all this, it could be a big problem.
Yes, exactly.
Yeah.
Fortunately, perhaps fortunately, as I mentioned last night, because we talked about this last night, we're having a minimum. According to the scientists, we may enter a period where there'll be absolutely no sunspots at all, the Mortar minimum. And that could go on for a number of years, and one has to wonder if whoever's watching out for us, and I hope there's somebody, has decided if we've got to have a flip, let's have low sun activity, right?
Yes. Well, that's, convenient. It certainly is. I think, Art, at the end of the day, what we're getting to is that eventually we have to learn to fly. I like to think of it that way. We have to learn.
We have to learn to fly?
Yeah, we have to learn exactly what is a gravitational field and how to modulate it so that we can actually live in space and not on the surface of a planet. Because surfaces of planets are very unstable. They can get disrupted by many different sources, like a meteorite large enough, a comet coming by too close, a sun flare, and so on. And, I think like planetary systems are like little incubators. They're good for a little while, but eventually you got to learn to fly, just like a bird in a nest, and get out of the nest before the next hurricane,
Fly, little bird, now, or you die.
Yeah, and I'm not the only one saying that. For instance, Stephen Hawking for years have been saying we have to learn. We have to figure out a way to colonize other planet or live in space. And all that cannot be done using fossil fuels in rockets. And so we have to learn how to use gravity.
How to really fly.
Yeah.
Again, I harken back. I harken back to Michio Kaku, Professor Kaku, and here's something he said. Maybe you agree on this one. He said that right now we are a Type 0 planet, or civilization, if you will, and that, in his opinion, though he's upped the chances a little bit, I asked him what are the chances of our surviving here on Earth if we don't find a way to get off the planet, and he thinks we really need to get off the planet just like you do. He said the odds of surviving if we don't get off the planet are really tiny. In other words, we'll end up with either ruining the planet, blowing ourselves up, or whatever.
Yeah, actually, I think we're living in grace. I'm just amazed we're still here to talk about it, like considering all the stuff that could happen that could wipe us out. It doesn't actually take that big of a meteorite to lose usable atmosphere and so on. And so it really is remarkable we're still here, but I think we shouldn't push our luck.
Well, Nassim, I've noticed something, and that is the scientists sort of try to reassure us by saying, well, they're looking for these things.
Yes.
However, you may have noticed that many, many times you see a newspaper article that says something, or a broadcast that says something like, yesterday, the Earth had a really close call. Well, so that means nobody noticed this thing was coming. Had this thing hit us, we'd be in big trouble. So too many times they find out about it after the fact.
Yeah, that's why they're recruiting groups of amateur astronomers everywhere on the planet to keep looking for these things. It's not obvious to be able to track these objects in the space of our solar system is very large, and by the time we see it, might be too late. So it's remarkable, like I was saying, that we're still here. But I think more prominently is that we have to be able to understand gravity, and this is why I've been pushing so hard in this last 30 years to try to find solutions that would give us a better understanding of gravity, how it works, and to apply those in laboratory to see if we can modulate gravity. And I've worked in laboratory for the last 15 years on this. And the equations I wrote tells us that gravity is a little bit different than what Einstein described.
Can I stop you there? You used the term modulate gravity. Oh, my. That is very, very interesting. Modulate. For example, folks, modulation, think of it like this. A radio wave is silent. It is there. And then once modulated, it has intelligence on it. And that's how you hear it come out of your radio. It's a modulated wave. So you're talking about modulating gravity. And then, as you pointed out earlier, we could fly. Is it in your view? You've thought a lot about this, obviously. Can we really modulate gravity?
Absolutely. I'm convinced we can. Just as we learn to modulate, as you were mentioning, the electromagnetic field, and pretty well all of our civilization came out of it. We learned that, we can use magnetic fields to produce electricity. We learned how to use the electromagnetic field as we got a better understanding of it. I think that the next step for civilization will be to learn how to interact and use the gravitational field and power our civilization out of it, and actually become a civilization that live in space, and that comes to the surface just to enjoy the garden that the Earth is.
Well, if what you say is possible, that would really mean that you could be in a small craft, begin modulating in some way that would, in essence, repel you from the Earth, and you could, if you wished, at the speed of your choice, rise until you left the atmosphere and were in space. You wouldn't have to be launching rockets and spewing chemicals everywhere, and really...
Exactly.
Right. So I was going to ask, is that how it could work?
Yeah, absolutely. You can think of it this way. It's like if you were to create a gravitational field,
yes,
strong enough above your head, eventually you would start getting sucked towards it. And if you were holding a device in your hand that's creating that really high energy gravitational field above your head, and you got sucked towards it, that point would move with you because you're holding the device, so you kept on getting sucked towards it. You would accelerate in that direction.
I would have thought it would be the other way around. In other words, gravity is what holds our feet to the ground. So if you were modulating gravity, would you not modulate it so that it pushed you away from the source of gravity that holds our feet to the ground? You said toward it.
Yeah, you can think of it the other way around as well. You can think of it as the depression that's occurring above you is creating a push below you that's pushing you away from the gravitational field of the Earth, for instance.
All right.
But if you continue to create this depression, and there's such a thing that just kind of made the media in the last few months called the EM drive, which is a little can that was discovered and invented by a very good physicist in England that kind of violates the laws of motion in the way we think of them today, but basically creates a little bit of a depression inside a closed can. It's a little cone of copper that has microwaves in it, right. And it's got more microwaves in the front and less in the back, and all of a sudden it starts moving. It propels itself, and it's not propelling against anything. It's not outputting any electromagnetic field or gases out the back end. It's just creating enough of a gradient in the structure of space that it starts to move towards a certain direction. And so some of the stuff that's emerging now, that's confirming some of what we just discussed.
Wait. Let's see if I can understand this. You're suggesting that what has been done is that somebody has sort of created, could it be described as a hole in front of the object that causes the object to move toward that? Is hole a wrong word?
It's more like a depression.
A depression,
a
okay.
Gradient.
Okay.
Yeah.
All right, so
exactly.
So scaled up, one could imagine a craft.
That's right. And this is why NASA has been testing this drive and got positive results from it.
NASA has been testing this drive?
Absolutely. NASA has been testing this drive. A gentleman called Sonny White at NASA that's running a specific program in which NASA is trying to produce a warp drive. Came across the EM drive, which this physicist, which was an excellent physicist, couldn't get anybody to test because many scientists said this violates the laws of motion. It's impossible. So it's got to be a hoax. So nobody would test it. Finally,
for goodness sake.
Yeah, it took him years, like some 10 years. Finally, the Chinese tested it with positive result, and now finally NASA tested it with positive result. And it does what it says it does. It does produce thrust without expelling anything off the back end. And this is why physicists said it violates the laws of motion, that if for any action you have to have a reaction or the other way around. Yeah. And so, but when the NASA, and this is really important, when NASA published the result of their test,
yes,
they mentioned very clearly in the abstract of the paper that most likely what this drive does is that it's pushing against the vacuum fluctuations at the quantum level. And here we are right back to some of the equations I wrote that describes matter in that way.
Okay, please repeat. NASA said
that basically what happens is that the density gradient, the change in density from the front of the cone to the back of the cone of this little drive, is creating a flow in the structure of space-time, in the fluctuations of the vacuum at the quantum level around it. You can think of it as like a fluid.
Well, there's no minor matter at all. In fact, if you were in space, you would just, check me if I'm wrong here, but if what you say is true, you would continually accelerate, right?
That's right.
Oh,
so,
well,
but if you're pushing against the quantum vacuum, you see, because that's even in space where it seems like there's nothing, at the very fine level, there's all this energy that's present in the structure of space-time itself. Actually, we can't find anywhere where there is not this electromagnetic energy. And what NASA said, and it's very significant.
Could it be dark matter?
Yeah, dark energy.
To initiate a dialogue sequence with Art Bell, please coordinate your phalanges and call 1-952-225-5278. That's 1-952-CALL-ART.
Nassim Haramein is my guest, and Wow, we're into some pretty interesting territory here. He's a theoretical physicist. You can look him up. You can read his papers if you wish. But some of what we're talking about, absolutely priceless if one of these days, as he feels, we're going to have to learn to fly. So here you are once again, Nassim. Thank you. This will be a fairly short span we've got here before the bottom of the hour break. But anyway, this incredible drive, is it fair to call it a drive? It could be a drive, right, for space travel?
Absolutely. It
All right.
produces trust. And although it's producing very little thrust right now, it is producing some, considering that only very little wattage of energy is put in the drive. With more energy, of course, more thrust.
Mm-hmm.
And, it is definitely the beginning of realizing that we may be able to interact with the structure of space-time and produce gravitational effects. There's another fellow, for instance, in the University of Finland, Eugene Poklaknov, that has succeeded in creating a gravitational beam that propagates at some 64 times the speed of light, and that's published in peer-reviewed journals as well. And so what I'm saying here is that, like, we're not that far. Like, people would think, oh my God, this is going to be like generations from now. I think it's actually imminent that we will be able to modulate gravity and control it.
Imminent is a really good word. And that really, I mean, you're right. It's the only way that we could move masses, if we had to or wanted to, from point A to point B. Also, if we were able to, I guess I'm going to ask this, if we were able to modulate gravity, how effective would it be, Sim, way out, for example, far from Earth? It's not, is it or does it not depend on its ability to repel from Earth's gravity, or once out in deep space, could you just accelerate endlessly?
Oh, absolutely, because space-time is everywhere, and so basically what you're doing is you're warping the fabric of space-time. You're kind of creating a funnel, just like maybe a little bit a propeller on a motor of an airplane or in a boat motor, is creating a depression, even either in the air or in the water, to create a force moving in a certain direction. You're basically doing that with the fabric of space-time wherever you are in the universe.
Okay, well, you heard me earlier, Nassim, mention what they're calling Earth 2.0, Kepler 452b. It is 1,400 light years from Earth. Now, to even in your wildest imagination, to think about getting to Earth 2.0, you would have to travel many times the speed of light to ever even imagine getting there in a single lifetime.
Right.
Is what you're suggesting with modulation of gravity something that would begin you on a trip that would get you there in some reasonable amount of time?
Yeah, this brings us back to the beginning of our conversation about wormholes, because if you're able to warp space-time, and this is what some of the fellows at NASA are working on, if you're able to warp space-time into a wormhole,
right,
then all of a sudden you could transfer the information across the universe extremely, almost instantaneously, as we were discussing.
Yes.
And you could be there, in a few seconds, with no jet lag. So yeah, I mean, all these technologies that are being developed now, and some of these effects that we're now starting to realize are occurring, and I want to mention, Art, that all these effects have to do with spin, and that's why I use the analogy of a propeller, and this is what was really missed earlier on, and that I believe is the key, is that spinning electromagnetic field at high velocity can produce these warps in space-time and open these wormholes. This is really becoming reality now. It's not just in the theoretical realm. Some of these devices are starting to show these effects.
Do you know some of the wildest stories that anybody's ever told? Things like the Philadelphia experiment involved spinning things.
That's right.
You're
Spinning
aware,
electromagnetic fields.
That's right. You're
correct.
aware of those stories, right?
Absolutely.
So you're suggesting there could be a real basis for. I mean, it's not. There's an old story, so
right.
A new theory, an old story.
Exactly, and it's just like this. Einstein described gravity as the curvature of space-time, and I don't know if we have enough time in this section, but I'm just going to start on it. Imagine that, let's describe it this way. Typically, it's described as the surface of a trampoline that you put a ball on it, and it curves the trampoline so that it curves the surface so that another ball would appear to be attracted to the first one, right?
All right, pick right up when we're done with the break. Relax. You've got a few minutes to relax. I love this stuff.
Right, exclusively on the Dark Matter Digital Network. This is Midnight in the Desert with your host, Art Bell. To call Art, please dial 1-952-225-5278. That's 1-952-CALL-ART.
Don't worry, everybody. We're going to get the lines open here at the top of the hour, maybe even earlier. I promise. I know when I get a really good guest and I get all wrapped up, it's hard to let go, but we will do that. We'll get the lines open, I promise. My guest, of course, is Nassim Haramein, and he is brilliant, absolutely brilliant. We're talking about modulating gravity, a drive for getting to another place in space that we could conceivably call home if we had to. All right, so I get messages, and believe it or not, something called the wormholes. I'm doing the program. They send it on the computer, and it comes blasting over here from Arizona. Lasha says, how can you create gravitational depressions in space if there's no gravity in space? It doesn't make sense to me.
Right. Well, there's gravity everywhere. For instance, our solar system is stuck in the gravitational field of our galaxy.
Yes.
And we know that our galaxy is part of a larger cluster.
Yes.
And that cluster is part of a supercluster. So there's gravitational fields everywhere, and space-time, the fabric of space, which produced the gravitational effect, is everywhere. There's no place where there's no space-time. And so, modulating space-time or curving space-time or warping space-time anywhere you are will produce gravitational effects. And if you're controlling those, you can make it so it propels you in one direction or another.
Okay.
So, yeah.
Continue. Go ahead.
Yeah, so I, before the break, I was saying that, like, and the problem, and that's known, is just the problem has been that the idea that we could curve space-time strong enough to produce such an effect has always been thought to be impossible because the amount of energy it would take to curve it. And so the example I was gonna give is that, and that's maybe just because of the way we describe gravity, meaning that Einstein described gravity as this curvature of space-time, just like a ball on a trampoline curving the surface.
Right.
I like to use a different analogy. Think of you being in your bathtub with a rubber ducky and and pulling the plug. And so you got this little vortex that's being created near the drain because there's a little gradient there. There's a density change. The air is coming up, the water is going down, and if you look on the surface of the water, it looks like it's curving towards the drain. And if you put your rubber ducky close enough,
he's going to die.
He's going to start orbiting and act very much like the way we think of gravity.
Right.
But, and so what Einstein described is very much that curvature that you see on the surface producing the gravitational effect. And that, demands tensor equations, and it's very complex. But what I found is that you can describe the same effect, get the same result, get the same math, except instead of describing the curvature, you describe the water molecule spinning, making the vortex in the first place, which is more fundamental. The curvature on the surface is kind of a secondary effect. The source of the gravitational field is actually all these little Planck fluctuations spinning together, producing that effect. And so the key word here is spin. So all of a sudden, you start to realize, wait, I might be able to curve space-time, not by creating this massive energy event, but just by getting space-time to spin.
All right. Have you ever heard the name Bob Lazar?
Absolutely.
All right. My friend Rossi sends me a message saying the electromagnetic drive is almost exactly what Bob Lazar described to you so many years ago. He talked about the sport ship drive on the UFO at S4, which used a depression of gravity in front of it, pulling it forward.
That's right. Yeah, that's correct. And many people that had some of the people that had these experiences, or and that's gonna sound pretty esoteric, but even the people that have been taken on spaceship by maybe another civilization,
yes,
describe these spinning magnetic fields or spinning electromagnetic events. And even when you look at some of the footage in modern time of some of these so-called UFOs or flying objects that we're not sure where they come from or how they get here, very commonly we see kind of the object wobbling in space. When it slows down enough, we see it like it almost looks like it's a little unstable.
That's right.
And that's called precession. And it's very much the result of spinning things. It's a gyroscopic effect. When you're spinning things, you can think of a top that you're spinning, those toys from when you were a kid.
Right, as they slow, they wobble.
Yeah, as they slow, they wobble. And that's called precession.
Very good.
And so you can imagine that a ship that's using spin in the electromagnetic field to propel themselves by curving space-time, when they slow down and stabilize,
got it,
or they slow down the drive so much that it starts to wobble just like a top.
Jacob says, if modulating gravity was possible one day, would it be possible to bend the space fabric to the point you could actually create a wormhole?
Absolutely. And this is what Sonny Whites and those folks at NASA are actually working on, because the math is very clear and straightforward that you could eventually create enough curvature to produce a wormhole and connect very distant places in the universe and travel instantaneously. It's very real. And as I was saying at the beginning of our interview, this might be actually occurring in nature all the time, even at the subatomic level, so that particles that are entangled are actually connected through wormholes.
Good. Back to entanglement. I want to come back for a moment to mass consciousness, because I really want to ask about this. If everything is connected, then mass consciousness really does, or the possibility of it really does make sense to me. Have you looked at the experiments done at Princeton and for example, as they monitored around the world with these so-called eggs, which are actually just computers spitting out random stuff, it just spiked through the roof before the 9/11 business, and then they have many other examples of spikes that occurred. And this claims to be looking at mass consciousness, at some sort of something, and here's the real wild part of it, that occurs before whatever it is that's going to happen, like 9/11, something really big. It occurs before it, which implies some sort of twist in time or knowledge of what's going to happen. I don't really know what it fully implies, but it fascinates me.
Yeah, it not only is it instantaneous, it seems like the communication is even, so past the speed of light to the point where
Yes.
it's a precursor, and you can actually, you could think of it that the events that we experience in our everyday life is actually a little bit slow compared to the underlying reality that's occurring. By the time we experienced it, it's actually, already passed by a few seconds.
Okay.
And so these eggs are actually, which are random generators that are all around the world network, that are supposed to be, spitting out random numbers.
Mm-hmm.
All of a sudden, when we have very significant global events that range from global meditations, by the way, to very dramatic events like 9/11, these generators start acting weird. They start to output coherent data, coherent spikes, and like you were mentioning, the spike starts to move towards higher levels of coherency prior even to the event occurring. And so
some kind of rift in space-time. It's really weird.
Yeah.
All right, here comes a big one. I lay
just
this
on that subject, or just
Yes.
one more.
Oh, by all means.
What's really cool is that some of these experiments are done as well with individuals trying to influence the random generators, and that's been shown to be very effective. With your consciousness, you can influence a computer that's outputting random numbers.
That's a fact. That's a fact. As a matter of fact, they turned out a little program that allowed you to do exactly that. It would sort of, you could get any background you wanted on the computer, and as you concentrated, you tried to manifest this picture to become solidified in front of you on the screen. If you didn't concentrate on it, it would go back into the noise. And I experimented with that, and I'm telling you, it really works.
It's remarkable, and it
Yes.
supports the concept that you're connected even to a computer.
Exactly.
And so it really kind of starts to land that, wow, we're really connected to this material world around us.
All right. Before we ever get to phones here, I really want to ask you if you believe that time travel in time, will actually ever become possible in either direction.
Mm-hmm. Well, that's a really good question, and it could take a long time to answer because we would, as well, like the concept of time might be erroneous the way we think about it. But just to give the standard answer would be that it's not precluded from Einstein field equation, meaning that even the standard model of physics predicts that time can be manipulated and that we should be able to travel in time. It might sound a little mind-boggling, but, when we actually start to modulate gravity,
Yes.
we may end up modulating time at the same time.
That's the same time, yes.
Yeah, because, it's space-time that we're affecting. And so the thing is that the way I see it from the perspective of the work I've done is that when you change time, you change space as well. And so that you are actually in a different place, not necessarily, at a different time. So you might not be on Earth anymore, that you might be on a, parallel or, a reflection Earth in space. But that's, going down the rabbit hole.
It is. How about questions about life and death? In other words, is it your view that when we, human beings, die, that's it, game over, nothing left? Or in physics, is there some way to, how can I put this? Imagine that something continues when we die.
Absolutely. Yeah,
absolutely. Really?
Yeah, meaning that like we know for a fact that no information can be lost. And so if you think of yourself, well, first of all, it's important to describe what we call death, because basically when
Be my guest, describe death.
Well, because all we observe is just a change of state, meaning that all the atoms you were ever made of and all the atoms you're made of currently are still there. They don't go anywhere. They just change state. They change form. And so if you thought about it that way, even in a very physical way, nothing really was lost. There's just a rearrangement of the information. And so I particularly believe that, the information still remains, and that it's in a different form, and it's in a form that's not necessarily directly accessible from our perspective, from our experience every day. But I don't see why some people wouldn't be able to access it, or that even technologically eventually we would be able to access it. If the information is in the structure of space.
If I'm hearing you correctly, you're talking about accessing information from people that, from our perspective, have died.
Exactly. That information is still present, and it may still be coherent.
What is that going to take? A quantum computer?
Yes, a quantum interacting device that is tapping into this field of information I was describing earlier. That's called the vacuum fluctuation. That makes up everything we see and don't see, according to what I found.
Wow, you have given me so much to think about. Holy mackerel! All right. Zim,
it's mind-boggling.
It absolutely does. You're in the mind-boggling business, no question about it. Nazim, give me a moment. We're going to take a break, but before we do, I wanted to, because we're a new show, I want to describe to people how to call. So hold tight. We'll be back with you after the break, and we will be taking calls. So here's the deal, folks. You know the phone number, the public phone number, right? It's area code 952-225-5278. That's 952-225-5278. That's an easy one to call. But then we've got ways you can call from all over the world. North America and Canada. Folks, you have got your own window to get in and ask a question. How can you not have a question after all of this? It's Skype. And what I'm suggesting to you is that you put Skype on your phone. If you've got whatever phone you've got, a smartphone, put it on your phone. And the way you set it up is, if you're in North America, Canada, whatever, go like you're going to make a new contact and put in simply, and it's not case sensitive, just put in MITD 51. MITD 51. And then you'll find that in your list, and you'll see the little phone symbol, and you can press on it, with Apple anyway. I've got Apple. Sorry if I offend the Android people. And then the same deal goes for international calls. If you're somewhere outside the North American universe, put in MITD 55. That's MITD 55. Now, again, it will appear in your contact list, right? And after it's in the list, you can go there, and even though we haven't connected as buds, you can call it anytime you want. And by the way, it's free. Absolutely free. And the reason I'm suggesting all this to all of you is because when you do call by Skype, oh my, you get really, really good connections, as you can tell. Tonight I've been talking to somebody in Paris, France. Well, guess what? Though we've had maybe a hiccup or two, what a connection from Paris, huh? Way better than the average phone company could do. So it's kind of necessary for me to take a moment out and explain to people how they can call. Now, you can also do that from the computer of your choice. Apple, or everybody's favorite, Windows, same deal. And of course, that's the way you receive the show. We come to you on the internet or on your local station, whatever the case may be, and through TuneIn. God bless TuneIn, getting us from here to there. So I hope I've explained it reasonably, because the phone lines are about to open. And we'd love to have your questions. Because, boy, this is really, really good stuff. I'm Art Bell, Midnight in the Desert, roaring.
To initiate a dialogue sequence with Art Bell, please direct your finger digits and call 1-952-225-5278. That's 1-952. Call Art.
Listen, everybody, one more thing. Let me add one more thing, and that is, if you have not experienced listening to this program with headphones, oh, baby, you're missing a lot. We're coming to you in full stereo, and the audio should be actually fairly impressive. It's quite an audio chain we've got. So next chance you get, if you haven't done it, grab some earbuds. I'm going to tell you how to get some really good ones from Bob Crane and listen to us in full living stereo. It is actually pretty impressive. And I'm not impressed easily by audio, but I'm telling you, it sounds really good. All right, Nassim, you're back on the air and hopefully prepared to answer a few questions.
Yes, wonderful.
Good. All right, well, here they come then. Let's start with Michael on Skype. Michael, you are on the air.
What a great show, Art.
Well, thank you.
You made an old retired concrete executive's brain cells start moving again. Nassim,
Yes.
let's say that, and I'm not being negative here, but let's say we're able to manipulate gravity and get 300 million people off of Earth and be able to transport them 4 times the speed of light to Earth 2.0. I guess my question is how do we sustain ourselves? We are organic orgasms here.
Maybe you are.
Organic people here. We need food and water.
Well, yeah, but Earth 2.0, sir, implies exactly that there would be things to sustain us there.
But wouldn't we have to plant?
Well,
food.
Well, take seeds.
Okay.
I don't know. All right. Thank you very much for the call. Yes, of course we would have to sustain ourselves, but if we could travel at the kind of speeds that Nassim is talking about, then it wouldn't be a problem. We could run back and get seeds or whatever.
That's right, and we may not have to go that far. Meaning, we could, for instance, terraform Mars very rapidly. I mean, there's many efforts right now, millions and millions of dollars being poured into trying to set up a little colony on Mars,
right.
And by very large private organizations. And, and they're planning on doing this with rockets, which is not really feasible. It would take thousands of rocket trips to put on Mars even a small community. But if you are able to control gravity, or you have gravity control, I mean, you could do trips within a few minutes to Mars. And you could easily, when you have this type of technology, when you have this type of power, of control, you can do all sorts of things that makes absolutely no sense with anything less. For instance, you can transport large amount of water. You can transport all kinds of materials. You can even capture materials that are floating around, like, for instance, in the asteroid belt, and bring them to where you need them, and so on.
Yeah, and you can even go back and get your rocket keys you left on Earth. If you. Anyway.
Right.
Let's go to the phone lines. There's so many people. You're on the air with Nassim. Hi.
Hi, Roswell's Art.
Thank you.
We talked almost 15 years ago about this exact same craft. I saw it at Edwards Air Force Base when I was called in to provide some support equipment to the government. And it took me a year to find out what it was. And a guy said it was counter-rotating magnetic fields that projected a hole
Yes.
that pulled the craft into whatever direction, and it went faster depending on how far out that hole was projected.
So, in other words, exactly what was described.
Exactly. It was at JPL Laboratory. I had to be cleared and all that. Never had to sign anything. I had one of those type jobs, like, you have a janitor. They're always there. They're always doing something, but you're never quite sure who they're with.
All right. Do you have an actual question for Nassim?
Is this craft's been around since the 80s? Will it be revealed soon, in your opinion? And I was told that there was probably 60 of these things back in '89 that were operational as part of Star Wars. Is there anything that you've heard about that?
All right. Yeah, let's actually ask him. Nassim, he's right. There are many who believe exactly what he said, that these craft that can do what you have described have been around for a relatively long time. Is there any chance, in your opinion, that all of this will get revealed to the world?
Yeah, I think so. I think that, many of these experiments that have been done in, behind the scene, what's typically described as black budgets in the military industrial complex, even since the Second World War and so on. I think that, now, it's emerging in the population, and it will become available. It'll become revealed, that and how to interact with the vacuum to produce energy and so on. These things are about to emerge, and it's going to change our world. It's going to rock our world, like at a very fundamental level.
I don't often say this. People have been saying it for years, and I've heard it, but I actually think our world is about to get rocked. I've got this impending feeling that I've come on the air at the right time because something really big is getting ready to happen, and I'll leave it at that. Matthew, you're on the air.
Hello, Art. So
Hi.
happy to have you back on the air.
Thank you so much.
I was wondering about the potential for using this technology, this wormhole technology. Theoretically, would it be feasible, say, to activate a wormhole in the Yellowstone caldera and have the other end, say, on the moon? And we could terraform the moon by moving the caldera to the moon?
Shifting real estate, huh? I don't know. That's pretty wild. Nassim, you want to answer it?
I never thought of it that way, but I would say probably yes, correct. We could move massive amount of material across wormholes to wherever we want it. And it would be very effective in terraforming and so on. Bringing in water. I mean, we could theoretically take a planet that looks like Mars or the moon, and bring water, produce atmospheres.
Sure.
I mean, literally, when you have control over gravity, you can do really incredible things.
And again, it's your view that we are going to need something like this because we're going to have a dire need to be off the planet en masse at some point.
Absolutely. And I think that any society in the universe that develop on any size planet eventually reach that point where there's just too many people, there's not enough resources,
right,
and they have to learn to fly.
Gotcha. All right, to the phones we go. It just says anonymous. I assume not that group. Anyway, it's not a group, not that massive.
Hi, Art.
Hi,
my name-
people. Yes, hi.
Hi. I was going to say that I think people might be overthinking these propulsion devices. Instead of thinking of it as anti-gravity or depressions in gravity, I don't see why you can't just take two magnetic elements, which normally people would think push apart or pull together like magnets do, but adjust the variables so that the fields propagating between them, instead of generating balanced forces, generate unbalanced or unidirectional forces where one field is pushing and the other is pulling in the same direction, and then you will get propulsion.
Nassim?
Very good. That's a little bit of what we're describing. It's a little more complex just because, you can't just get a magnetic field to attract to another one if you don't have the other one in front of it. So, it's a little, but it's along those lines. You're using magnetic fields, you're spinning them at high velocity, like the experiments in Finland from Eugene, where he's spinning a high density magnetic field in a superconductive disk and getting this beam of gravity coming off it. This is very much what you're describing. I think you get the right thinking. The theory is always a little more complex, but I think that's the right views that you have.
You have to remember this.
Go ahead. No. Go ahead, caller.
When you have fields propagating between two elements, they take time to travel. And during that you're not just they travel at the speed of light, so people forget that they think they happen instantaneously. But in the time that the fields travel, let's say from one element to the other, you can adjust the conditions in the facing element so that when that field arrives, it'll be pushing on one and pulling on the other. It's possible to do. It's a simple formula, actually.
Yes, that's correct. And it's just that in terms of overcoming the gravitational field, those propagating fields, those electromagnetic propagating fields, have to interact with space-time so that gravity is modulated as a result. That's where the complexity gets a little higher. Because the magnetic fields, like the source of the magnetic fields, are unknown in physics, meaning we don't know why an electron is an electron and why, a proton has an electromagnetic or electrostatic field. These are starting to be discovered to be actually part of this curvature in space-time that's occurring at the quantum level. And so you're correct. Using the propagation of magnetic field in the structure of space-time, we can curve space-time and produce those effects. And I think spin is the very important component of it.
Apparently. Scott on Skype, you're on Midnight. Hi.
Hi, Art. This is my first call using Skype, so I hope you can hear me okay.
You're doing very well. Are you on a computer or a phone?
I'm on an iPhone using earbuds and a built-in mic.
Sounds like $1 million. Proceed.
Okay, send me some of that. Anyway, last hour, Nassim mentioned something regarding information about the departed, and that it might be possible using a supercomputer to reach them.
Yes.
And I did that actually in 1986.
Well, then you need to call me tomorrow night. I mean, obviously there's a big story here.
Okay, yes, there is, and I'm willing to tell you, and the lady that taught me how to do it is a psychic who I would love to have on your show. But I will call during open phones and discuss this, because it'll knock your socks off. So wear socks.
I will wear socks. I will be ready for you. Make sure and call me. All right.
Okay, man.
All right. Take care. Oh my. All right. We're going to do an early break, trying to squeeze as much as I can in. You know the phone numbers. You know the Skype way in, I hope. Now, there was an example of somebody who did it. And boy, does it ever work. If you use Skype the right way on your smartphone, you'll sound like $1 million, but I'm not going to send anything out.
Want to take a ride? From the high desert and the great American Southwest, this is Midnight in the Desert, exclusively on the Dark Matter Digital Network. To call the show, dial 1-952-CALL-ART. That's 1-952-225-5278.
Hi, everybody. I'm Art Bell, and this is Midnight in the Desert. Very, very busy night. I'm going to find out if Nassim is still... Are you still there?
Yeah, absolutely.
Good. There was somebody trying to get in from Asia, and I think that I brought them on, but not successfully because it somehow put you on hold, so I didn't answer it the right way. I'm going to learn how to do it. So the caller from Asia, give it another try, and we'll give it another try. And in the meantime, Hello there in Marysville something. You're on the air.
Yeah, hi. My name is John. I'm actually in Yuba City, right next to Marysville.
All right.
I have a couple. Hey, first of all, thank you, Art. You've been such a big part of my life for so long, and I'm so glad you're back.
Thank you.
I have a couple questions for your guest. You guys touched earlier on pole shift.
Right.
And I would like to know a little, I'd like to elaborate on it a little bit, some specifics, like how it would affect our electronics, our basic electronics.
Right.
Internet and GPS, satellites and stuff like that.
Really good question.
Most of our defense and everything is relying on that, and I don't understand what would happen with a pole shift. Is it like positive to negative as far as electronics are concerned? You know what I'm saying?
Right. It would have a very devastating effect on many of our devices. Already the fact that the poles are drifting is, running havoc with some of the navigation systems for airplanes. They have to readjust the coordinates for landing strips and so on. Because of the change.
Actually, that happened down in Florida. They had to actually reorient runways or something. It was a big mess down there because of it.
That's right. Because of the pole drifting.
Yes.
So it really could produce some very big challenges on our planet if the pole shift happened in a very sudden way, especially. If it's more gradual, we may be able to adjust some of our technologies. But as we were discussing earlier, if it dropped dramatically in strength, it would be a big problem in terms of the radiation we receive both from the galactic cosmic rays and from our sun. So go ahead.
Go ahead, caller.
No, I'm sorry. I thought that our magnetic field is decreasing now, and that's an indication of pole shift. Is that correct?
That's correct. It is decreasing, or it has been seen
to be. Would it be stronger? It will rebuild itself?
It will, yes. It's assumed that it would rebuild after the flip, as we can see from the records in the lava. And we do see from the records in the lava, spotting, and we see various weakening of the field prior to the pole shifts. So all these things are precursors.
Seems to me it's the devil in the details of the flip that we need to know about.
Yeah, exactly. It's not so well known because, of course, we don't have any records of any technological civilizations undergoing a pole shift. So we don't know exactly what it will do and how exactly it's going to do it.
Here's a question for you, one that you haven't addressed yet, Nassim, and it's how quickly or how long might it take for the flip to actually occur? Maybe this question you can't answer. I mean, is it overnight? Is it like, oh my God, it just flipped? Or is it over 100 years or 1,000?
Well, that's the thing. It was first believed that it would take hundreds of years.
Yes.
And then some of the latest data is showing no, it can happen very, very quickly in a matter of a few days. So, it can be very rapid.
Okay. All right, caller, does that answer?
Yeah, that was awesome. I do have one other quick question. He mentioned earlier that NASA was working on creating a wormhole. Some guys at NASA were
I'm not sure he said that. I don't know. I don't think he said that.
He also mentioned...
I don't think he said that. No, I don't think he said they were working on making a wormhole. He said they were working on a drive, I believe.
Warp drive.
Warp drive,
right.
yes.
Yeah, exactly. Sonny White and his team are working on using those fluctuations at the quantum level to energize a drive that would produce warping of space-time, which can lead to wormholes.
If NASA starts to make a wormhole, you'll let us know right away, won't you?
Yes, I'll give you a call.
All right. Very quickly on Skype, Ra, I believe it is. You're on the air.
Hey, thanks. I really appreciate it. I just have a quick question for Nassim about time travel, because I know you guys were talking about it earlier, and I find that very interesting.
So do I.
How do you feel about like the butterfly effect and the ripple effect and paradoxes and stuff like that? Because it seems to make time travel really complicated. Because if you go back in time, eventually in the future someone would go back in time. Would it mess up the current timeline, or does time fix itself?
Well, that's a really good question.
There's a lot of questions, actually. The butterfly effect was asked about.
Uh-huh.
Yeah.
All right, let him answer. What about the butterfly effect? In other words, explain what the butterfly effect is.
Well, the idea that if you went back in time and killed your grandpa, would you be there to,
that's
kill him in the first place?
Yeah, that's a big paradox. The butterfly effect is like, well, if for example you went back and you made some wind, right? Wind, a little bit of wind. It might, in the future, cause a full-blown typhoon that kills millions.
That's right.
Right?
Right. The butterfly effect is that a small change could create a very large change eventually.
Yes.
And, directly related to the butterfly effect, I think there's something that's misunderstood about that, and is that, for instance, the idea that and that's why it's called that way, like that a butterfly in Africa could bat its wing and all of a sudden eventually produce a hurricane in Florida. There's scale relationships in the universe that are very fundamental to the way the universe functions, according to what I found. And these scales have to do with the impact of things on other things. Like, for instance, our Earth has very little impact on the sun. It doesn't even look like a grain of sand beside the sun. It's very, very teeny. The sun can have a very large impact on the Earth, though, and so the same for the butterfly, meaning that, like, if the butterfly bats its wing, the probability of that eventually producing a hurricane are extremely, extremely low.
Right.
It would take millions and millions of butterflies batting their wings all at the same time, and then maybe the probability would go up a little bit. So,
all right. Let's talk about the granddad thing. You go back and you kill somebody in your lineage, your grandfather, whatever.
Mm-hmm.
That's just impossible, right? Because you would blink out. It would be when the moment the bullet hit and he died, you wouldn't exist, or what?
Right. Well, this is assuming that all these timelines are singular and linear. But actually, if the timelines are parallel to each other, you will not necessarily experience that in the reality that you're in. Meaning, if you go back in time, you might be back in time in a universe that may not be the one that you're experiencing right now. And in that one, you may kill your grandfather and not exist anymore.
So
but
would you, in essence,
exist here.
Okay, would you be blowing yourself into a new dimension, essentially?
Right. You'd be experiencing a different universe.
Okay, caller, does that answer it?
Beautiful. Thank you. Exactly what I was looking for.
All right. I'm glad we were able to deliver. Take care. Boy, we're short on time. Very quickly, Tampa, Florida. It's midnight. You're on. Hi.
Hi, Art. Jimmy. How are you doing, Art?
Good. Jimmy, we don't have much time. What kind of question?
Basically, I just want to say hello. Welcome back.
Oh, thank you.
You're not doing radio gold tonight, Art. You're doing radio platinum. You're way out there, dude. I would love to talk to Mr. Nassim.
Yes.
And ask him, I got a question and I've got a statement, basically.
Okay.
Should I just go ahead and say it?
No. You shouldn't. Okay. I'm going to just pot you right down, and I'm going to tell you that there's not enough time for you to do that. So, tick, 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 tick. We'll be back. I'm Art Bell, and this is Midnight in the Desert.
For Dark Matter News, I'm Leo Ashcraft. Have you ever regretted sending an email and wish you could take it back? Or maybe you've worried about sending confidential information over email, especially after seeing the damage a large-scale email hack can cause, like the one that hit Sony Pictures last year. A new self-destructing email service called Dmail aims to eliminate those concerns. The introduction of a tool that allows you to better control your messages that are sent over Gmail. With Dmail, you can revoke access to any email at any time, and in a release arriving soon, you'll be able to stop recipients from forwarding your messages to others too. The idea for the new service comes from the team behind the social bookmarking service Delicious, a longtime web staple. Eventually, the team plans to make Dmail a freemium service, where some aspects will remain free for individuals, while power users and businesses will pay for other features. You don't normally hear about leprosy cases today in the United States, but a warning has gone out to Floridians to beware. 9 cases have been reported in the state so far this year, and the cause is thought to be armadillos. What's the connection? Armadillos are common in Florida, and according to the Centers for Disease Control and Prevention, they are the only animal to carry leprosy, a bacterial disease that affects the skin and nerves. Each of the Florida cases this year involved people who were in direct contact with the armadillos, and the disease could be spread through saliva. What's more startling, the Department of Health reports that an average of 10 Floridians are diagnosed every year, so having 9 people already infected this year is a huge jump. While armadillos are nocturnal, it is currently breeding season, so experts warn that you may come across some babies during the day. They may be cute. They can also carry the disease. So make sure you and your kids stay clear of armadillos. This is Dark Matter News. The FDA has approved a device that lets the blind see with their tongue. Developed by Wisconsin-based WICAB, the device translates visual information from a video camera into gentle electrical stimuli on the tongue. Eventually, users are able to interpret the signals to see where objects are located, how big they are, and how quickly and in what direction they're moving. If only Nikola Tesla were alive to see this now. A group of Russian physicists are picking up from where he had left off, using his patents and ideas to finally create the masterpiece that had been long suppressed, wireless electricity transmission. Their work has been largely forgotten. And just like Tesla himself, they have not reached their funding goals, but they still seem to be publishing updates regardless. In 1891, Nikola Tesla gave a lecture for the members of the American Institute of Electrical Engineers in New York City, where he made a striking demonstration. In each hand, he held a gas discharge tube, an early version of the modern fluorescent tube. The tubes were not connected to any wires, but nonetheless they glowed brightly during his demonstration. Wireless electricity transmission solves a number of problems. It allows people to receive electricity without large-scale infrastructure costs. Transmission to remote locations becomes feasible, and terrain is no longer a restriction. This one invention could well grant billions of people access to life-empowering electricity, assuming they succeed. Imagine watching TV via the power of lightning. By using the Earth as a dynamo, or by making use of the existing potential difference between the ionosphere and the Earth, Tesla had hoped to be able to generate electric charge, which would be then dissipated around the world. The man was ambitious. Tesla's ambitions were thwarted by money. The first real Tesla tower, the Wardenclyffe Tower, was near completion and showed encouraging signs. The project would be abandoned when Tesla himself spent all of his savings on the project. I'm Leo Ashcraft for Dark Matter News.
Again, back to Paris, France. And Nassim, you still in place, I presume?
Yes, I am.
Good. All right, I believe we were talking with somebody in Middletown, Connecticut, and hopefully you're still there. Proceed, sir.
Oh, I'm absolutely still here.
Okay, good.
I'd like to preface this question for your guest with, I'm an evil billionaire. And,
it's the Donald!
No. Well, no. Instead of running for president this year, I decided that I would love to build an anti-gravity chamber in my house.
Okay.
But I have some concerns.
Okay.
And hoping your guest can answer them. When I'm floating in the air, now I kidnapped some of the best scientists from around the world to work on this, but they seem to not be able to answer the question of fire. Will I be able to smoke my marijuana as I float?
Because if I can't float to a bag of Cheetos, I don't want to do it.
Well, that probably leads to the question. One way to travel would be to, modulate gravity, and this guy obviously travels a different way. He waited all that time to say that. Sheesh.
Oh my God, if I knew, I could have reduced my 30 years research long ago.
Yeah. Adam on Skype, you're on the air with Nassim.
Hey, Art. You sound better than ever on this digital network here.
Oh, it is. It's pretty cool, isn't it?
Oh man, it sounds good.
Yeah.
You're fascinating guest there tonight, and he mentioned CERN earlier, and I had got just a couple questions for him about the people over at CERN.
Mm-hmm.
You hear about these increases in their TeVs, that they're spinning these particles around faster and faster and faster. And then you also hear about, the closer you get to the speed of light, the more and more energy it takes. And I just thought it would be interesting from a practical standpoint. When they go from 6.5 to 13 TeV, which is, I guess, a little over double, or at double, they don't, I guess it's not linear as far as increasing the speed of these particles over there. Are they getting close to a point where there's a really diminishing return because of putting so much more energy in, but not getting that much closer to the speed of light? Is that a concern for them? And the second part of that CERN question was, is it really anything to worry about a black hole being created out of the research over at CERN that just gobbles up the planet?
Well, as I was saying earlier, actually, there is an outside possibility in the mathematics that could occur, and that's what has created so much concern in some of the scientific community and the public. Absolutely, more energy you're putting into those things, there is a diminishing return as you get closer and closer to the speed of light. And there's more and more time variations that are occurring. It gets very complex, and it demands a lot of energy. And at the end of the day, and there's other physicists that would agree with this, the whole concept of smashing particles together to figure out how they work may not be a completely valid concept. And so it's really not clear that this is leading to something very practical and fundamental in our understanding of the universe.
Nassim, I want to interject something. When we exploded the first atom bomb, I think there were many, many scientists who thought, when they press that button, there is going to be a chain reaction in the atmosphere, and we're all going to die. Now, I'm not saying that everybody thought that, but many, many legitimate scientists thought that. And,
right.
Yeah, but they still pushed the button.
They still pushed the button. I know, it's remarkable. I mean, there's it's a little bit the same situation. There's an outside possibility that we could create a large enough energy event that it would create some disturbance. And generally, the scientific community doesn't believe so, but the fact is that the math does show that there's an outside possibility, and that's what has been creating a lot of controversy. As far as the validity of the experiment itself, I think there's a really good book, if you're interested, that's called The Higgs Fake, by Alexander Hundbricker, which is a scientist from Germany, and I'm sorry, Unziker is his last name, and it's an excellent book because it gives a really good overall view, and certainly from his perspective, of the standard model of physics and why these experiments are not necessarily valid.
Well, they found the Higgs particle, right?
They say they did, but that's the point, is when you do the analysis at the end of the day, it's really unclear that they found anything.
Well, now they're looking for something they claim smaller than Higgs.
Right. But this is the problem with these accelerators. We've been doing this for a few decades now, is that, we're always going to want to build a larger one and get a smaller particle. And my point is that that's not necessarily, a valid exploration. Maybe we should understand how these particles interact with each other. What is the geometry of the field? And, instead of trying to get a smaller and smaller and smaller particles. We might be able to do this to infinity. I mean, and it's been like that. We keep wanting to build larger accelerator and get smaller particles so that a few scientists can get a Nobel Prize for having discovered it.
Gotcha.
And that book actually, is a nice analysis of this. And it shows that the complexity in the model that's being used right now is so high, and it's so unclear what we're actually finding, that it's not necessarily a valid exploration.
All right, Wayne in Michigan, your turn. We're running out of time. Hi, Wayne.
No, we don't want you to give your last name on the air, okay? So.
Oh, I'm sorry. Well, this is Javier.
Okay, that's fine.
Okay. And first of all, I gotta say thank you for coming back on the airwaves.
You're most welcome.
I have been listening to you since I was 15 years old. I am 37 now.
Thanks for that.
And I have a question for your guest tonight.
Yes.
Mr. Nassim Haramein.
Mm-hmm. Very good.
Yes.
It's a hard pronunciation. Haramein, yes.
Yes. You're in Paris, France. I have one of my cousins is a diplomat, actually, and he works at the Salvadorian embassy in Paris, France.
All right, sir. Do you have a question? Because we're way short on time here.
I do. I'm so sorry. Okay. My question is, how do you create the because if you're traveling, you have to basically you are pulling instead of pushing.
Mm-hmm.
If you know what I'm saying.
He knows what you're saying. He set that up.
Mm-hmm.
He's the one who told you. Yes.
Yes. Well, how do you create such a vast depression, basically?
Okay, that's a very good question. I'm going to hold it right there. The depression that you're rushing toward to get that acceleration is what he's asking, how you create it.
Right. Well, that's the thing, and that's why, although this was thought of and theoretically thought as a possibility, it always was thought that it would take so much energy to create such a depression. Mm-hmm. But what we're discovering right now is that actually it's only would take such an energy if you're not spinning the field. But if you're spinning the field, there's some new elements that are showing that actually space-time tend to want to spin with you. Mm-hmm. And it creates that depression with much less energy requirements, and that it's actually achievable even with very little energy. For instance, in the cases of the Finland experiments, or in the case of the EM drive. So actually making this depression may not be that hard, and in fact, from what I found, that this kind of depression are being created naturally by our universe, and that's what actually produces everything we see, the material world we see.
Well,
there are little vortices, depression in space-time that we call atoms.
Maybe it will teach us. Lead the way, as it were. Mike on Skype, you're on.
Hey, Art. Just wanted to say you and Nassim have been the most fascinating thing I've ever heard. I'm very happy to be a part of that.
Thank you.
My question here tonight is, earlier we had talked about this idea that information kind of persists. And so my question is, does that open up the possibility of teleportation if we're able to extract that information and reconstruct it?
Ooh, interesting.
Very good. Absolutely. It does do that. It does predict that this kind of stuff can happen, and it has been somewhat achieved by various experiments, some in Australia, the Sydney universities, where they were able to teleport photons of a laser beam and so on. So it actually is in the works as well. This beam me up Scuddy thing could be a possibility, absolutely. And as well, you know what, Art, some caller earlier, we were talking about psychic phenomena and so on. This new view of the universe where there's this field of information that connects us all of a sudden, starts to explain phenomena that have been in the folklore for hundreds of years about people being able to remote view places they've never been at.
Yes.
And all these things, remote healing, all this stuff. It starts to make sense.
It starts to connect the dots.
Universe.
It connects the dots.
Right. Exactly.
Mike, does that answer it?
It absolutely does. Thank you, guys. Nassim, I'm going to go download your paper tonight and just tear into it. Thank you.
All right. Thank you very
much.
Good on you. Nassim, let me ask you, do you have a website? Do you have, I understand you teach some kind of online course. Tell us what you can about this while we have time.
Yes, well, we have a website called resonance.is, resonant is. People can go there and download my papers. There's all sorts of information. Actually, what's really cool to read is the articles that we publish there. So if you go to the news and frequently asked questions, you can get on our articles list. And actually, we just published an article on the EM drive and all this stuff. And as well, we have an online academy with a very extensive course that gives all of the details of the theory, what it means, how it applies to our lives. And every month I go online and I answer all the questions that people have that are taking the course. And so there's all sorts of ways people can participate. They can become a member of our foundation, nonprofit foundation, research foundation, and get updates on what we're doing and all this. So resonance.is is our website.
What a neat URL, resonance.is.
Yeah.
On the phone, hello there, you're on Midnight.
Hello?
Yes, hi.
Hi, Art.
Yes.
Hi, Art.
Oh man, this is wonderful to talk to you.
Well, thank you.
Absolutely wonderful. Real quick, I think we're missing the big point here that he's trying to tell us, and that it has to do with spin. And I think that the theory of everything is going to come down to this idea of spin, because if you look at our solar system, if you look at our planets, if you look at even molecules and atoms, I believe that the very protons and electrons and everything like that even spin.
I don't think that we missed it at all. I think that he laid it out very well earlier. I don't think we missed it.
I'm just saying. I'm saying that he was talking about the idea that he's trying to figure out an equation for the theory of everything.
Oh, I see. Yes.
And I think that that spin, this concept of spin, may that the equation that he's looking for may be in this idea. And just real quick, I even think that the Big Bang has this expansion, but I also think that it's also spins. I think that the Big Bang also has a spin to it, and not just an expansion, and that the universe itself is actually spinning.
I think you're absolutely right. We are so out of time. One last call, maybe. Cedar Rapids, very quickly. You're on Midnight. Hi.
Hi.
Good. Go.
My name is Brett. I'm in Cedar Rapids.
Okay, and you have a question.
For the guest, about waves. Particles, we all know about particles and atoms and whatnot. And is there a way that there could be waves that would create the particles?
Yeah, very good. Absolutely. In fact, particles may be waves in the structure of space-time. As I was describing, basically a particle is not like a billiard ball. It's a field that's being generated in the structure of space-time itself. And that field is being generated because it's a little vortex. You can think of it as a little eddy in the structure of the vacuum at the quantum level, and this is how I solve those equations. So absolutely, these particles appears as particles, but they're actually little waveforms in the structure of space-time.
That's it. We're out of time. My friend, it has been an honor to have you on the program. You've been amazing, and we're going to have you back again.
Art, it's my honor, and thank you so much for having me.
And, gee, tough it out there in Paris, huh?
Thank you.
Take care. That's it, folks. We're out of time, but boy, what a program, huh? From the high desert and the great American Southwest, have a good night, all.